During this chapter, we will set up our project database and learn to work with database migration files. We're going to begin by looking at the fundamentals of databases. In the last chapter, we learned about the main loop of the request-response cycle, from the browser to the controller to the view and back to the browser. Over the next few chapters, we're going to shift our focus to the model and database portion of this diagram. We could start by learning how to create a model without a database first, and then add in the database connectivity later, but most models in Rails will be connected to database tables. And in real-world development, the process of creating those models usually begins by first defining the database tables. So that's where we'll start too. If you've never worked with a database before, chances are that you have worked with a spreadsheet like Microsoft Excel. A database is similar in that it has columns and rows which are populated with data. A spreadsheet page is what we refer to as a database table. And you can have multiple tables, the same way that many spreadsheets often let you have different worksheets or tabs that you can switch between. The spreadsheet columns are the table fields that define what data will be stored, for example, first name and last name. The rows are the individual records. If I have 20 customers, then I have 20 rows. Each row can have data in each column. Now, while this can be a useful analogy, databases are not spreadsheets. A database can define and traverse relationships between tables. That's why we call them relational databases. And relationships are very powerful. Spreadsheets don't give you that. The other big difference is that when working with databases, we're going to be issuing commands in order to interact with the database. With the spreadsheet, we have all of the tables and rows and columns laid out in front of us in a visual medium. With databases, we won't have that. We're going to be working with subsets of the data all the time. We'll issue commands to the database, it will return bits of data to us, or we'll issue other commands that will then manipulate the data that's in the database. And perhaps it goes without saying, but spreadsheets are optimized for adding numbers. That's what they do best. Databases are optimized for working with data, especially relational data, and that's what they do best. I realize some of you may not have extensive experience with databases, so the question comes up, how much SQL do you need to know? It is possible to just follow along with me, stumble through the unfamiliar parts if necessary, and still make it work. But ideally, you should go and learn some SQL on your own. Rails is going to provide a very friendly layer over SQL so that you don't have to write SQL very often, but it is going to be helpful to understand what Rails is doing for you behind the curtain and to understand the concepts that it's using. Every now and then, the SQL does still show through, and sometimes you will need to write a little bit of SQL. There's a special vocabulary associated with databases. Let's walk through a few of the most important terms together. Not only will this ensure that we're all on the same page, but I will also give you an idea of how these terms fit within the Rails framework. First, we have a database, which is simply a set of tables. It's not the same thing as a table. Sometimes people use those words ambiguously. A database is a collection of database tables. And in Rails, one application typically equals one database. It doesn't have to be true, but at the beginner and most basic level, it's always true. Our sample application that we'll be working with is going to have only one database. An example name for the database might be simple_CMS_development. The name is typically all lowercase with underscores, which is the Rails convention. We can of course configure it to use something different if we like. Databases are going to be the level where we're going to grant access permissions. We don't have specific table permissions so that some people can view some tables but not others. We're going to give our Rails application permission to access the whole database and then let the application decide whether a user ought to be able to access certain tables. If the database is a set of tables, then a table is going to be a set of columns and rows. In the Rails framework, one model equals one table. We can have models that aren't connected to databases, but most often every model has a corresponding table. The model and the table represent a single concept, a noun, the what's of our application. For example, in the simple CMS that we build, the nouns might be the users, the subjects, the pages. In other applications, they might be the products, the customers, or the orders. These table names are also all lowercase with underscores, and they're plural, because the table will contain many rows of this type of item. We have many subjects in a subjects table, so we pluralize it. Again, you can customize the naming, but this is the Rails convention. Tables are where relationships are going to be defined. We'll talk more about relationships in just a moment. The next term that we have is column. A column is going to be a set of data of a single simple type. In the Rails framework, a single attribute of a model is equal to a column. For example, first name, last name, email, and password would all be attributes of our user model, and they would be columns in our table as well. When I say a column has a single simple type, what I mean is that it has a type like a string or an integer, that kind of thing. A table is made up of columns and also of rows. Rows are the data. Each row is equal to an object or an instance of a model. In the case of our users, a row would contain all of the data about one user. So for example, we might have Kevin, Skoglund, and an email address. And that would correspond to the columns first name, last name, and email. Next, we have a field, which is the intersection of a column and a row. It has a single value. An example of that might be the first name field, where we have the value Kevin. Our next term is index. An index is a data structure on a table that's going to increase the lookup speed. It's like the index at the back of a book. It lets you find rows in the database very quickly. Next, I want to talk about foreign keys. Foreign keys are an important concept when working with relational databases. A foreign key is a table column whose values reference rows in another table. They relate rows in one table to another through this reference. These relationships that foreign keys provide are why we call them relational databases. An example might be that if we had a pages table, we would have a subject ID in that table, and that would reference the ID of the subject table. Notice that it uses a singular foreign table name. We don't say subjects ID with an S, it's subject singular underscore ID. It corresponds to a subject in our subjects table, and then we put the ID at the end. Again, this is the Rails convention, and it can be overridden. If you've worked with databases before, this will be a familiar concept. If not, don't worry, we'll come back to it again in greater detail later. One important point about foreign keys, though, is that you always want to put indexes on your foreign keys so that you can look up those relationships very quickly. Next, we have the term schema. The schema is going to be the structural definition of a database. It defines the tables, the columns, the indexes, everything that makes up the database. And if we import a schema into our database, it will create a complete database for us. It would have no data in it, but it would have the correct structure. And the last term I want to introduce you to is CRUD. You're going to hear me saying this a lot in the coming chapters. It's an acronym for create, read, update, and delete. And these are the four main ways that we interact with the database. We create new rows of data, we read existing rows of data, we update those existing rows of data with new data, or we delete rows of data. Okay, now that we have some of those fundamental concepts out of the way, let's create a database.